Hello again, everyone. Welcome back to the final part of our 10-part series. So just to recap how far we've come, we have gone through an overview of why we would want to basically stream social media data and use a technology like Hadoop. We've actually installed Hadoop in the Amazon cloud. We've set up a Twitter app, streamed the Twitter data to Flume. We have that landing into our Hadoop file system. We have Hive installed and configured. We can query against the data streaming to the Hadoop file system. We have Uzi running in the background to maintain the partitions, and it will add the partitions, making it available to query through Hive. And then finally, in the last part, we set up an ODBC connection, ran some basic queries against the data. So this is kind of the view and how far we've taken it. In this final installation, we'll preview how you can extend this footprint by adding another social media source like Facebook, how you can perform some sentiment analysis against the data using a desktop tool. And then finally, we will just have some parting thoughts and can perhaps put a bow on this. And I hope you find this useful. Again, this is coming from a perspective where I didn't really know how to get this environment, really to do this, let's say a month ago. And through all these resources, through sort of the troubleshooting, I kind of landed at, okay, here's how you do it. So if you found this helpful, please provide that feedback either on the YouTube page. You can tweet me at DataDanSandler, or just comment on my blog where I'm very active in posting on big data topics. So here's what we're going to do today. I'm going to kind of show you how I've configured Facebook, and I'll give a demo of how we are streaming Facebook data to our environment. It's very different, and that's kind of why I wanted to show it side by side with Twitter, how we stream the Twitter data. After that, I'll get into the sentiment analysis, which introduces some of the data science behind taking social media and analyzing it in a way that you can take unstructured data, sort of measure subjectivity and sentiment, and how you can begin to cluster the information in a methodical way. So, first and foremost, the way Facebook is going to, how we're going to stream Facebook data is very different than Twitter. Twitter, we used Twitter4j, we opened up a stream factory, and everything was it was basically a custom source, which is what's labeled here. So you basically set up, you have the Twitter source and the Twitter source properties, define what the parameters are for our Twitter stream, for example, the consumer key and the access key. And so Twitter needs those keys and those properties to open up the stream. Facebook requires a very different mechanism. So if those familiar with Facebook, you can develop apps, of course, mobile apps, web apps, whatever. So what you have to do is you're going to set up a real-time subscription through a Facebook app that you create. And one thing I should mention is that Twitter social media and Facebook social media are very different. Twitter casts a very wide net, though the depth of information you can receive is fairly limited. You could basically get some information about the tweet, and I should say relative to the Facebook data. Facebook data, you can get not just the comments, the likes. There's a much broader set of information that comes with Facebook interactions. Plus, there's all the underlying. You can basically get corresponding profiles of people. So basically, it's open to what people allow you to see, and if you see interactions, you can find you can basically get all of the information related to the people in the interaction itself. So if someone's liking something, you can go up, find their profile, and you can stream that. And it's all through the, if you've heard of Facebook graph search, basically we're using the same API to access all that information. And it's really triggered off of any of these likes or comments. The Facebook app will basically say, okay, the level of information you want, so it's at a page level, it's at a feed level. You can get very granular or very broad and basically get a pretty large object back. You set up the level in which you want to subscribe to it. The Facebook app is going to subscribe to in your real-time subscription. You're going to, at that point, Facebook needs to authenticate the app in what you're basically using to stream the data. So in this case, it's going to do an HTTP GET. It's going to get the token back and say, okay, this app is authenticated based on the authentication information that's registered at the time you set up the Facebook app. What will then happen is we can do an HTTP post, which basically means we're going to we're going to use the Facebook Graph API to get back a JSON object which says the information from here that we want to grab in the level that we set up in our real-time subscription will be posted to Flume, okay? And that's what the Flume HTTP source is. So HTTP source is a relatively new feature within Flume as a source. I believe it's as of 1.1. So once we get the JSON object back from Facebook, we're going to do a post to Flume, which runs basically runs its own embedded web server. So it's running Derby in the background. So the Derby HTTP, it basically runs the embedded web server, and it will post to a port that you set up, and for Derby to listen to, and then at that point it will receive the data from the JSON data from Facebook and put it to the Hadoop file system in the same manner in which the Twitter data is streaming. So we're going to have underneath the /user, we have a tweets folder on the Hadoop file system. We're going to have a /user Facebook folder, and then whenever the year, month, day, whatever that happens to be, we'll have that added streaming to our Hadoop file system. So I'm just going to demo this, and then I'll show you the Flume configuration. For those interested in the source code, please reach out to me at DataDanSandler, and I can, or comment to the YouTube page, and I don't have a GitHub account. If there's critical mass, I'll do so. Otherwise, like I said, I'm a data guy, so I don't usually reach out to, I don't necessarily see a potential to have critical mass unless, of course, there's enough people that really demand it. Okay? So I'm just going to do a test. So one thing in the process of debugging my Facebook app, I've created a little script. Okay, so it's called test.php. What this is going to do, it's going to do just a portion of this interaction here. It's just going to do the call to the Facebook Graph API, get the data back, and then do an HTTP post here. Okay, so that's all I'm going to show. And we can see here we have the Flume log that I'm tailing. I have the Apache log that I'm tailing. So just so you know, Apache, of course, is needed in this scenario because Facebook needs a callback URL, okay, to do the authentication and then to do the post. Okay. So the first thing I'm going to do is I'm going to see if there's anything. There should be one file out here, so you can see that we have streamed one one Facebook post to our Hadoop file system within this hour. We're going to do another one here by php-f, and then we're just going to run this as a script. Okay, so this is a URL. You can see here that it's already streaming the data to the Facebook, and basically YYYYMMDD hour. Okay, so I'll now go back. I'll see what so there's two files out there, and then I'll cat this temp file. Too late. I'll just so basically it's going to get back, I just did a test, and so this is a fairly limited amount of information, but once we actually have more sort of, and Facebook is very interactive, you can see likes, you can see comments, all of that will be centered around this original feed. And as that comes down, you'll see who it was, who posted, who reposted, that sort of thing, who liked. You can see a lot more information. And that's what I'm going to show you right now. I'm going to go to my Facebook page. Okay. I'll go back to one more thing. I want to get the Apache blog. So I'm going to like this. I'm going to actually I'll comment on this first. So test this process. So we should see in the Apache log we should see let's see here. So basically this will capture the tweets that are streaming as well as the so we'll give it some time. Facebook is not this is not as fast as the Twitter streaming data. There's of course a different completely different mechanism with which to get that information. It's a little bit slower. So we'll give it some time. So you can see here that it's starting to create that file, and just see what that looks like right now. Okay, so it has the original information and then test this process, and then it would have the name. From there, the name and the ID, we could then go back and get the information about this user, the Facebook user. And because it's public information, there's nothing preventing us from getting more detailed information about this. So if you're a company and you want to see who's interacting, what sort of interactions are taking place, this is a way to do that. And one more thing, I can like this. So I'll like this comment. Okay. So this should also generate its own stream. We're getting close to 1 at the top of the hour, but this should fit within the window, so it'll still be in the 12 o'clock folder. And after this, I'll show you the Flume configuration. This is one thing I should mention. So there's what's happening is that the HTTP post is actually, so there's the like right there. The HTTP post is going to an Apache, so I basically have a very simple web Apache server running in this environment. It's basically running on port 80, of course, and basically the callback URL will go to a PHP script. So basically I have a very simple PHP callback URL that Facebook will call to say, okay, authenticate, come back, and then get the HTTP post to post to the from Flume to the Hadoop file system. Okay. So we now have a new file. And what we should see is a like. In addition to this information, we should have the like, the corresponding like. So somewhere in here is the like. Okay. So this kind of, yeah, likes one. So you can basically see how many people have liked it, who's liked it, that sort of thing. So that kind of shows you this behind the scenes. I'll now show you the Flume configuration. Okay. So in addition to this is the Flume config file, which lives under /etc/flume-ng/config or conf. The flume.config contains the properties of the agent that's running. So here we have a single agent, social agent, which corresponds to this file, which is the etc default flume ng agent. So I basically called it a social agent because we can run multiple streams, Flume streams underneath this agent. Okay. This corresponds to the root of our properties. So social agent, sources. So here's a space separated list. So we actually have 2 sources, 2 channels, 2 sinks. I'm going to just bring up. So Flume is a very it's a very flexible streaming mechanism. It can be very simple, like this. Sorry, like this right here. Web server, source, channel, sink, and then Hadoop file system. What we have is actually 1 agent, 2 sources, 2 channels, 2 sinks. We actually want to separate these out completely, so you can probably get into a scenario where it makes sense to have a source, 2 channels, 2 sinks. You know, you get very kind of elaborate in your Flume configuration. This is about, at least for this exercise, we have 1 agent, 2 sources, 2 channels, 2 sinks. I didn't want to confuse them. I just wanted a very straightforward setup. So the difference between the Twitter stream and our Facebook stream is that Facebook is using an HTTP source, which is a default class, whereas Twitter is actually using a custom source. Okay, because it's actually defined. We saw the source code in, I believe it was part 5 of our series when we set up the Flume agent. Okay, so we're going to specify the port that's running, that Flume is running on. So one thing I do want to show you is go back here. So I'll go to the log directory, Flume ng log. Sorry, it's right there. I'll look at Flume init. And I'm sorry, I misspoke earlier. Instead of running Derby, which is the embedded database, it's running Jetty. Jetty is the embedded app server, so I apologize before I misspoke. So you can actually see it in the Flume log, this when it actually initializes. Sorry. You can see here it's Jetty. It's basically starting up. It's running on this port, okay, and it's also got logging. So Twitter stream. So basically, this kind of shows you when you start this up, everything is streaming. And so let me get back to, yeah. See, these all correspond to the properties in our. See that FB, so that Hadoop file system and the FB Hadoop file system, that corresponds to the sync that we defined here. Okay, so there's, this is how it all ties together from the Flume configuration right to the log. Okay, you can see where the port was running, and this is so these interceptors tell the type. So basically, it's kind of like its own sort of name-value pair. You can say interceptors, this is the name, and you have interceptor timestamp type. So this is all part of the HTTP source documentation with Apache Flume. So basically I just said you need a timestamp interceptor, which is just a name I gave it. The timestamp name here corresponds to a type, which is this timestamp interceptor builder, which allows us to basically do this HDFS path, okay, which says it's very similar to the HDFS path for the Twitter stream, but it's basically going to the Twitter, it's going to the Facebook level, it's not going to the tweets path. And then we have a type, so all this I've kept as the same between the two feeds, okay. So again, that kind of gives you a more detailed understanding of how to configure Flume for two sources, two streaming sources, two channels, two syncs. And in this case, two different source types, one HTTP source, the other is a custom source. Again, if there's critical mass, if you'd like the source code, reach out to me, and if there's critical mass, I'll just post this on GitHub. Okay, so that kind of shows the Facebook streaming portion of the demo. Now I want to show the sentiment analysis. Okay, so what we're looking at here is a desktop tool. It's actually, it could be a full-blown server, but for the sake of just playing around and doing some rudimentary sentiment analysis, I came across a couple of white papers published by this company called Nime. So just to plug their white papers, they have one on social media data clustering, and there's another one here on basically it's both on, one is on sentiment analysis. They're both pretty much on sentiment analysis and social media intelligence and how you go about clustering the information, the approach you take. They provide some visualizations, so it's very, very helpful to get your head around, okay, because at the end of the day, this data is unstructured. How can we actually begin to measure sentiment if the information isn't structured? So that's where I took all of their relevant examples, and they have all their projects posted here. You can basically piece them together to take the data that's in our tweets table, and also use another input, which is listed here, which is so this is a subjectivity corpus. It's a multi-perspective question answer. So it basically from the University of Pittsburgh, and lists out basically words. It's kind of like a dictionary. words, what its type is, subjective, strong subjective, weak subjective, whether it's negative, or what the polarity is of the word. Because at the end of the day, the information within the tweet can connotate some sort of level of whether it's positive or negative. And so how this, having a word list like this, and there's others, but this was one of the more useful ones I found. And this was also the one referenced within the KNIME documentation. This is basically allowed us to tag each of these tweets. These tweets are literally treated as documents. So who the author is really the username. The tweet is a document. The categories are the hashtags, and you can basically begin to tag. So here we go through a process of tagging the tweets. Okay, positive, negative, neutral. Okay, and I'm not going to go too deep into KNIME, unless of course that's, again, I think I mentioned this in part 9. The data science portion of this is its own sort of tutorial, its own series, could be 20 parts. I can, if enough people reach out to me, I can publish this, and I mean, it's no skin off my teeth. So what happens is it creates a bag of words, and that bag of words allows us to do things like measure the term frequency, and that allows us to generate a word cloud. So I'll just show you what that looks like here. Okay, so again, this is basically looking at all the tweets and the most frequently occurring words, and the larger words are the more frequent ones. The green and the colors represent sentiment: green positive, gray neutral, red negative. So in most cases, the people are positively tweeting on the topic of big data. Some are neutral, some are negative, but for the most part it's positive. So tag clouds, if you were to tier the level of visualization, it's definitely a lower tier visualization. A more interesting, and I thought this was, to me, as a business user, maybe not so interesting, but as a data person, the network diagram that you can generate is just phenomenal. So we're going to do that right now. So what I found is best practice is you don't want to just take all the topics and munch them together. You want to take maybe a subset and filter those out. So what I've looked at here is just anything that is filtered on the Hadoop hashtag. And I want to see who's at the center of this discussion. Who's the leader, who's the follower. Okay. So I'm going to reset this. Just 1 second. And this desktop environment's its own sort of, that's again its own tutorial. Okay, so this allows us to receive and basically receive the data from KNIME, and we can diagram the network. So I'll just execute this. Oops. One second. Sorry about that. I'm not sure what happened. I just restarted this this Viz1 plugin. So let me just start up the console. I'll activate KNIME. Basically, that means it's listening for the data that KNIME's about to send it. Okay, I'll reset this. Then I'm going to execute. That will transfer the data over. So now we have all the data sent over from the tweet. So basically this is, again, centered around the Hadoop hashtag. Anyone who tweeted on that comes through and we can diagram it. So this kind of looks like a whole bunch of stuff. So to make this a little bit more readable, we're going to do 2 things. First things first, let's label and rank. So this is where the attributes that come over, and some of the, basically as you diagram the network, it basically adds a bunch of metrics to say who's the hub, who's the center, centrality, all that good stuff. Okay. So we're going to say rank, sending on the node weight on the, I'll say the hub score. Okay. Apply. I will also change the configuration. This is what the label is, so I don't want the ID, I want the NIME ID. The NIME ID is essentially we pass that over from, which basically is this is the screen name that comes in from Twitter, NIME ID. Okay, so this just doesn't necessarily get into the state that we want. So one thing we're going to do is analyze. Going to use, analyze degree percentage, and analyze this. And we're going to visualize. So by visualizing, we're going to change the layout. So instead of stress minimization, we're going to do centrality, which you can see here, it's a little better, but instead of uniform, we want degree percentage. This, yes, that's better. Okay, so we can already see that, okay, Hortonworks is at the center, so that's kind of a lot of people are either mentioning or responding to Hortonworks, which makes sense. They're a leader in this space. Cloudera is off to the side, not too far off. Visual intelligence, so these are all, I mean, this is starting to beginning to make sense. But to make this a little bit more presentable, we're going to change the color of the node to, based on hub score, we're going to saturate the color. Okay, so the hub score is basically, the higher the hub score, the darker the color. Makes sense. Finally, we will adjust the size based on the same property. There we go. So this gives you a relative, so the more nodes touching the center node, you can see the larger the object is. And again, it conveys, okay, really the larger, more colorful, centered objects are the ones that are the leaders in this particular topic. Works, Cloudera, Elite IBM Big Data, so this all makes sense. And this is where, if you're interested in saying who is tweeting on sort of the topics you're interested in, whether it's a product, a brand, a promotion, this helps. Okay, I found this very interesting. It's not something you can sort of quantify, but it's kind of like the way, you know, you take an article, run a word cloud, it conveys, okay, what were the common themes. This is a little bit more, I think, a scientific representation of leaders in the space. But finally, you can begin to get some more report-centric conveyance of the information. So here we're going to look at, there's a bunch of bubble charts here, scatter charts. I'm just going to show you this one bubble plot. Okay. Actually, this one is a little bit better. Yeah. So here we've taken across the board the authority. So basically, authority is measured by people who have either a high degree of followers or responses generated by their tweets, have the larger objects and the higher authority score. Then on the x-axis we have good bad rating. So this is based on the polarity. So yellow is neutral, green positive, and red is negative. So good thing is that those that are negative are not as do not have a high authority. But you probably want to look into this cluster here. This here, I mean, overall you'd like to trend this, so you know, over time, are the people with the highest authority the ones, do they begin to have more positive sentiment? Does that snapshot change? So there's a lot of analysis that you could do, and a lot of that could be done over time. And then finally, our good friends at NIME have a very provide this basically so one thing I should mention is NIME embeds a lot of open source tools and projects within their desktop tool and their server tool. So you can basically, this is BERT, so BERT is of course open source reporting, and I'll go back once I show you this report. I'll go back and I'll show you some of the other open source widgets that they have available. So we're going to view the report. So this is, again, I haven't really changed anything. I took this report as is, I plugged it into my data source, and it can generate a report that looks like this. So it clusters, uses actually some clustering techniques to do 10 clusters by size, authority, the deviation of the authority score, the hub score. So the hub score is, who is at the center of these discussions, kind of like the leader, and then the good bad rating. So leader is, you can begin to segment the population. Leader equals high authority score, low hub score, because basically they're the ones who are driving a lot of the sentiment and a lot of the interaction within this topic. Followers, high hubs, low authority rating. So the ones following the hubs and have a low authority. And finally, positive thinker, negative thinker, high, low, middle. Okay. So this is just the summary. So like this cluster we'd want to investigate. There's only 2 individuals in this cluster. We can begin to dive into that. So this is the leader versus follower, so authority versus hub. And you can see here that it's clustered around this section here. And cluster 7 seems to have a lot of neutral sentiment. Majority of them are positive, and then there's this red one here. This is, I think, a little bit more dispersed, where we have clusters of sentiment within these groups. So the leaders have the higher authority score, and the good bad rating that obviously measures the sentiment. So these are the users in cluster 3, cluster 1. So you can begin to dive into each one of those clusters and see which one of these are the leaders, followers, and begin to center in and focus in on one particular user or not. So this is my first sort of entry into the data science visualization. There's some natural language processing, not a whole lot of machine learning. For something like that, you'd need Apache Mahout, for example. I'm not skilled enough to use Mahout. Be interested in seeing a tutorial on that. Okay, but getting back to this workflow. So there's a bunch of nodes here. NIME calls it a node repository. So you can look at, like, if you're doing a lot of analysis on chemistry data, ChemAxon, that's a plugin that they use. Distance matrix, R, statistical R, so you can basically have, you do a lot of R programming, you can plug that in here. For the statistical analysis, we did k-means clustering, we did cluster assignment, so that's basically how we got the 10 clusters in the report we saw earlier. So, with that said, let's go back to the presentation. So, big data, Hadoop, and social media. This can all be done in less than a day. I was surprised to see, because I had in my mind Hadoop as this very large footprint. It would take, to get anything out of it meaningful, and you'd need 50 nodes in your cluster to stream social media data. You would need to be a Java ninja to make that happen. The fact is, you don't. You do have to understand the environments. You have to have some technical foundation, SQL, Linux, Apache, some Java, working understanding of Java. Um, you, with that said, you can do all of this in under a day. You follow these steps, each part within the series. Um, it's measured right now. All the 9 videos before this came in at 3 hours and 15 minutes. This one will come in about half an hour, so you're looking at 4.5 hours. I'm confident this can be done in less than a day. I'm very interested in your thoughts. Very interested in how you've taken similar, either other social media, or especially on the data science, data visualization side, how you've analyzed measured sentiment. Reach out to me. I'm also interested on the quality of these videos, making sure that these are technically, sound, making sure that these are accurate. I've left this as real time, so the only time I paused briefly was to troubleshoot, and I haven't left anything. I've just let this thing run otherwise, no editing. So comment on these videos. Reach out to me at DataDanSandler on Twitter. That's at DataDanSandler. Follow me on my blog, www.datadansandler.com. And I wish you luck. Let me know how this goes. Feedback is welcome. Take care.